The last lot of trig equations we want to deal with are ones that are quadratic. So we can have ones that come down to being a quadratic, and they might be in a nice factorised form for us, or they could be in an unfactorised form, and then you need to start doing some factorisation. So if they're not factorised for you, you need to factorise first, which is going to be very important. Also, we're going to realise if we can have solutions or we can't have solutions. There's some we might come across that you won't have solutions for. So let's have a look at the first one. It's set up nicely because we've got sine theta outside of 2 sine theta. So we've got a product of two things equaling 0. So if it's not equal to 0, well, I can't do this. I have to have it equal to 0, like all quadratic equations. So this case, sine theta, if that's equal to 0, the whole thing's equal to 0. So where is sine of theta equal to 0? Well, that's equal to anything on the x-axis. 0, 180, or 360 degrees. 2 sine of theta minus 1 would be equal to 0, because that's what's inside the bracket. If that's equal to 0, the whole thing would be equal to 0 as well. So if sine of theta is equal to a half then, because we manipulate that to get sine of theta is equal to half, our related angle will be 30, and sine's positive in the first and the second, so we take 30 away from 180 to give us the 150. So there's our two solutions. We're getting back to equations, nice linear equations as such, for our values in theta, and being able to solve those. This time again, it's nicely factorised, equal to 0, so 2 cos x plus 1 would equal 0. So cos x is equal to minus a half, our related angle 60, and we're in the second and the third quadrant. So we subtract 60 from 180 to give us 120, add 60 to 180 to give us 240. So there's our two solutions for this first part. And then we've got cos of x plus 1 is equal to 0 as well, because that was the other bracket. Where is cos of x equal to minus 1? Well, that would be at 180. There's only one solution for that. There's only one place. Tan alpha plus root 3 and tan alpha minus 1. Again, nicely factorised, equal to 0. So I can set two brackets equal to 0 and solve. Tan alpha is equal to minus root 3. So alpha is 120 or 300. Or tan alpha minus 1 is equal to 0. So again, we're in the first quadrant, so related angles 245, and it's positive also in the third quadrant, so 180 minus plus 45 gives you 225. So there's our solutions to that equation. Again, getting them back down to what we've had before. This one's not factorised, so we have to do some factorisation for it. So we look at what we've got. It's equal to 0 there. There's no constants, so we've got a common factor of cos x. So we can factorise cos x outside of the bracket of 2 cos x plus 1. So cos x is equal to 0. Where is cos x equal to 0? At 90 or 270 degrees. So we need to remember those situations where cos x is equal to 0. 2 cos x plus 1 is equal to 0, which comes down to cos x is equal to minus a half. So again, a related angle 60, and we're in the second and the third quadrant, so we subtract 60 from 180 and add 60 to 180 to give us our solutions there. So factorise first and then be able to do that. This time we've got a constant, so we've got a quadratic trinomial, so we have to solve it. We have to factorise it. It should factorise nicely. Again, you could use quadratic formula. That would be fine. You would do the quadratic formula and have cos x would come down to two solutions, a half n minus 1, by using the quadratic formula and using that as a, b would be 1, c would be minus 1. So you could do it that way, and you just have, instead of solving for x, you're solving for cos x. And then eventually you get to those solutions, which will allow you to get down to the values you need for x. Or factorise. It's not a hard factorisation. 2 cos x times cos x. The 2 cos x times 1 and cos x times minus 1 would give you a positive cos x when you add those terms together. The minus 1 times the minus 1 gives you the minus 1. So you can see how that factorisation works out to be that. If you want to, you can do a substitution and just let u be equal to cos of x there, and then have 2u squared plus u minus 1 equal to 0, and then solve that. That'll come down to 2u minus 1 and u plus 1. Then do your substitution back in for cos of x and you're back there. If that helps, that's okay. So we take our first bracket, 2 cos x minus 1 comes down to cos of x being equal to a half. Related angle of 60 degrees in the first quadrant, and it's positive, so it's in the first and the fourth quadrant. So we get 360 minus 60 gives us 300. Cos of x comes down to be equal to minus 1 there, and it's, like we said before, x is only equal to 180 there. There's only one solution for cos of x being equal to minus 1. Again, we've got a trinomial. It's factorise. We get down to 3 tan x minus 1, tan x minus 1. So 3 tan x minus 1 equals 0. So we get 1/3 for being tan of x. Again, we can't get an exact value like we've been getting before. Get an approximation. Our approximate related angle, inverse tan of 1 on root 3, would be 18 degrees. So tan's positive in the first, so that's why we keep with the 18. And it's positive in the third, so we add 18 to 180 degrees, so that's where we get the 198. Tan of x is equal to 1 from the second bracket. So again, related angle will be 45, and tan's also positive in the third quadrant, which gives us 225 when we add 45 to 180 degrees. So there's some examples of quadratic equations. Some were easier, some a little bit harder because you have to do more manipulation. Just where it gets harder is depending on how much manipulation you need to do. But again, get down to your brackets, solve your brackets like we've done with all quadratic equations. Solve those linear equations, except you're solving linear trig equations, but you still work out and get them as we've done before in the other videos, all the other working there.